All right, let's dive right in. We're going to talk about something that's, absolutely critical for any AI project, but it's often overlooked. It's called model evaluation. This is where the rubber meets the road, where we figure out if a model is actually doing its job long after the exciting part, the initial build, is over.
It's a pretty wild thought. You can have a project that looks like a total success. The model's built, it works great in a controlled lab environment. But that is not the end of the story. Not even close. Out in the real world, a huge number of these projects just quietly start to fail.
So that's the big question, right? Why would a perfectly good model suddenly go bad in the real world after you've already popped the champagne? Well, it's not because of some big dramatic event. It's usually because of a lack of one simple thing: continuous evaluation.
So how do we prevent this silent failure? The best way is to stop thinking of evaluation as the last step. Instead, think of it like an ongoing investigation. You have to constantly be asking the tough questions to make sure your AI hasn't gone off the rails.
And these questions go way beyond just a simple accuracy score. Yeah, of course we ask, is it right? But maybe the more important question is, how is it wrong? What actually happens when it makes a mistake? Is it a tiny little hiccup, or is it a total catastrophe? And, the real bottom line is always this. Is the model actually doing the job we built it for? Is it solving the business problem?
And that brings us to a really crucial idea. See, you've got to measure success in two totally different ways. On one hand, you have your technology KPIs, the nerdy stuff like accuracy, precision, error rates. And yeah, they're super important, but they're not the whole story. On the other hand, you have the business KPIs. Is this model making us money? Is it saving us time? Did we get the ROI we were promised? You can have a model that's 99% accurate and still be a complete and total business failure.
Okay, so if a model starts out great, ticking all the boxes for both tech and business metrics, what makes it go bad? Well, the main villain in this whole story is a sneaky little concept called drift. It's this silent force that just eats away at a model's performance over time.
So the first type of drift is called data drift. I want you to think about it like this. When you train a model, you're basically giving it a snapshot of the world at one specific moment. But the world doesn't just stand still, right? People change their buying habits, the economy shifts, new slang pops up. So when the live, real-world data that's flowing into your model no longer looks anything like the data it trained on, that's data drift.
And when you have data drift, it leads directly to our main bad guy, model drift. This is the part you can actually measure. It's the decay of your model's performance. Because the world changed, the rules the model learned are just not true anymore. Its predictions get worse and worse and worse. So let's just boil it down. Data drift is the cause, and model drift is the effect. Simple as that. When the input data gets weird and no longer reflects reality, the model's output, its predictions, is going to get weird too. Okay, so we've met the villain. How do we fight back? Well, the number one weapon we have in the battle against drift is something every single AI team needs to get really good at: model retraining. And model retraining is, well, pretty much exactly what it sounds like. You take the model that's already out there working and you train it all over again. But this time, you use a fresh, new set of data that actually shows what the world looks like today. It's this constant, iterative cycle that keeps your model from getting stale and out of touch.
Right. But that leads us to the million-dollar question. How do you know when it's the right time to retrain? If you do it too often, it can be super expensive and a waste of resources. But if you wait too long, well, your model is out there in the wild making bad calls.
So there are basically two main ways to go about this. The first one is super simple. Just retrain on a schedule, maybe once a month or once a quarter. This is a good idea if you just know your data changes all the time. The other way is a bit more advanced. You set up performance triggers. Think of these like an alarm system for your model. They're constantly running statistical checks, and the second your model's performance drops below a certain line, bam, the alarm goes off and you know it's time to retrain. But what happens when even retraining isn't enough? Sometimes you retrain the model and it's still just not good. This is when you have to make a tough call and execute a strategic retreat, which means going back to square one or maybe square two or three. Sometimes the problem is the model itself. Even with fresh data, it just can't hit its targets. That means you've got to go all the way back to model development. Maybe the fundamental architecture is just wrong for the problem now. Now, if the model design seems solid, maybe the problem is the ingredients. You might need to go back to data preparation. Maybe you need better labeling, or you need to augment your data in new ways to get a better result.
An even deeper issue could be that your initial assumptions about the data were just wrong. This means going way back to data understanding. The real world isn't behaving the way you thought it would, and you need to figure out why.
And then there's the biggest, most painful retreat of all. What if you tune everything? You get the best data, the best architecture, and you still can't hit your business KPIs. That means you have to go all the way back to the very beginning to business understanding. It means there's a huge disconnect between what the model can actually do and what the business really needs.
Okay, enough theory. Let's make this real. Because the true stakes of all this evaluation stuff become crystal clear when you look at how it actually plays out on the front lines, where every single decision has a real-world consequence.
Take a look at this. It's from a NASA project for predicting aircraft engine failure. Now, don't worry about all the boxes. Just look at that number in the top right. 7. That means the model completely missed 7 engines that were actually about to fail. We call those false negatives.
So if you just do the math, the model was right 91 out of 100 times. That's 91% accuracy. Hey, that's an A-, right? Sounds pretty good on a PowerPoint slide. But let me ask you, when we are talking about jet engines, is 91% accuracy good enough? I think we both know the answer to that.
For NASA, a false negative, missing an engine that's about to fail, is absolutely catastrophic. The cost isn't just money, it's about safety. Now let's look at a completely different problem. Coca-Cola using an AI to make sure their brand doesn't show up next to harmful content online. For them, a false negative means their logo appears next to something horrible. The business impact is also catastrophic, just a different kind of catastrophe.
And this, right here, is the absolute key to everything. The definition of a bad mistake is completely different for every single business problem. For NASA and Coke, false negatives are the nightmare scenario. But think about your email spam filter. A false positive, a real, important email getting sent to spam. That's probably way worse than a spam email getting through. You absolutely have to know which type of error your business cannot tolerate.
So I'm going to leave you with this question to think about. When is an AI project really a success? Is it the day you build the model and pop the champagne? Or is it every single day after that when you can prove that it's still right, still working, and still delivering value? Because real success isn't a launch party. It's a never-ending process.
Thanks for tuning in to this explainer.